Hi, in the last video, we got Kafka running locally using Docker. Now it's time to connect the dots. How does our Spring Boot application actually talk to Kafka? In Spring Boot, we need to do two things: produce messages into Kafka and consume messages from Kafka. And to make that happen, we set up some simple configuration. We'll set up producer settings, consumer settings, a Kafka template to send events, and a listener factory to receive events. By the end of this video, our Spring Boot app will actually publish and consume Kafka messages, just like services do in real banking architecture. So let's start wiring Kafka into our Spring Boot application. The first thing we do is to head over to our application.yml. Why? Because this is where we tell Spring where Kafka is running and how our app should talk to it. Remember, Kafka is already running locally on localhost 9092, thanks to Docker. So in application.yml, we configure the bootstrap server, the consumer group, and a few basic settings for sending and receiving messages. Let me show you exactly what that looks like. First, we tell Spring where our Kafka is running using bootstrap servers. In our case, as we discussed, it's just localhost 9092 because Kafka is running on our machine through Docker. Next, we set the consumer group ID. That's basically how our app identifies itself to Kafka as a unique consumer group. By default, we are using payment org consumers v1. Then we have auto offset reset as earliest. All that means is if consumer has never read messages before, start from the beginning of the topic rather than skipping ahead. Now about serialization. Kafka stores everything as bytes, not as strings. So when we send messages, the serializer converts strings to bytes. And when we read messages, the deserializer converts bytes back into strings. That's it. Finally, listener type is set as single, just means each listener processes one record at a time, which is the default behavior, and it's totally fine for us. Now that we have seen what Kafka needs from our application.yml, it's time to move to the next piece of the puzzle: how our Spring Boot application actually uses these settings to talk to Kafka. This is where KafkaConfig.java comes in. Think of it as a bridge between Spring Boot and Kafka. It uses the values from application.yml and builds everything we need to send and receive messages reliably. In our Spring Boot app, Kafka config basically does two things. It tells Spring how to produce messages into Kafka. Also, it tells Spring how to consume messages from Kafka. Here's how it works piece by piece. Consumer Factory. So this Consumer Factory creates our Kafka consumers. It reads all the Kafka connection details from the application.yml, like bootstrap servers, group ID, and offset settings, and makes sure the incoming messages are deserialized as strings. In simple terms, this is how we receive messages from Kafka. Listener Factory. This takes the consumer and actually runs it in the background. It powers the annotation Kafka listener methods, and it can handle multiple partitions in parallel. So this part is basically, this is how Spring listens to Kafka topics. Then we have Producer Factory. This creates our Kafka producers. Again, it pulls the bootstrap server settings from application.yml file, but here we also add reliability settings like ACKS is equal to all, idempotency is equal to true. So we avoid duplicates and ensure guaranteed delivery. In short, this is how we safely prepare messages to send. Then finally we have Kafka template. This one is the cherry on top. It wraps the producer logic and gives us a clean send method. So in our application, sending an event is literally one line of code, KafkaTemplate.send, meaning this is how we actually publish events into Kafka. So at this point, we have covered a solid amount of Kafka, enough to actually use it in a real payments architecture. In the last couple of videos, we have got Kafka running locally using Docker, explored Kafka topics, partitions, and consumer groups, and configured the Kafka inside our Spring Boot application with both application.yml and KafkaConfig.java. So now Kafka isn't just running, it's wired into our app and ready for action, which means the fun part begins next. In the upcoming video, we are going to publish real events and consume them, and build out the actual bill payment flow end to end. Now that the foundation is strong, we can finally make the payments architecture talk the way real banking systems do.